All right, so for Math 3, Unit 3, Objective 2, we're going to be looking at graphing polynomial functions. So one of the things that we're going to have to know is our degree again. So this is from our first objective. So is it odd or even? And we're also going to have to know our leading coefficient. Is it positive or is it negative, right? So these are all important things. So let's just start with like that positive leading coefficient, negative leading coefficient. So if I have a positive coefficient, that means the right side is going to go up. So positive leading coefficient, the right side goes up. But if I have a negative, right, negative leading coefficient, the right side will go down. Negative leading coefficient, right side goes down. And then our last idea is that whole odd degree, even degree. So if it's odd degree, right, so odd degree, the ends go in opposite directions, right? So one went up, one goes down. One goes up, one goes down. But if it's an even degree, they go in the same direction. So if the left side's up, the right side's up. If the right side's down, the left side is down, right? So even and odd. Another skill set we're going to need for this is finding our x-intercepts. So whenever we look to find our x-intercepts, we're always going to let y equal 0. And then we're going to solve for factors. So we're going to be looking for factors and solving each of those to help us find our x-intercepts. To find our y-intercept, we are going to let x equal 0 and solve for y. And then finally, we're also going to have to figure out our multiplicity, which is the number of times a factor occurs. So if we have something like, I don't know, x squared, x plus 3 to the 4th or something like that, if I want to know the multiplicity, I'm just looking at that power. So if it's a power of 2, I have a multiplicity of 2. If I have a power of 4, I have a multiplicity of 4. All right, so let's go ahead and take a look at this first question. So we are going to want to find the x and y intercepts. So we're looking for x and y intercepts, and we also have to state the multiplicity. So for our x-intercepts, all we have to do is take each of our factors and equal them to 0. So it's factored all the way through. So I have x squared. I want to equal that to 0, and then I'm just going to put a little wiggle through it. I have x minus 4, so I want to let that equal 0. And finally, x plus 5, and let that equal 0. And then I just solve like I normally would. So here I would square root to get rid of the squared. So that would be x is equal to the root of 0, which is 0. But it would have a multiplicity of 2 because there is a power of 2. So it means the factor just shows up twice. X squared is x times x, and that's why I write m2 multiplicity of 2. And then on the middle one, I want to add 4 to both sides. So that cancels. So then I would have x is equal to 4. And this would be a multiplicity of 1 because it's a power of 1, right? So this is a power of 1. So a multiplicity of 1. And for this one, subtract 5 from both sides. So I would get x equals negative 5. And the multiplicity here would be 1 as well because I have a power of 1. All right, and then let's find our y-intercept. So our y-intercept is when we let x equal 0. So I'm going to take that original equation, so this one right here, and wherever I see an x value, I'm going to turn that into a 0. So instead of x squared, it will become 0 squared. Instead of x minus 4, 0 minus 4. And then instead of x plus 5, 0 plus 5. So again, all I'm doing is taking all of those x's and replacing them with 0. So 0 squared is 0 times 0, which is 0. 0 minus 4 is negative 4. 0 plus 5 is 5. If I multiply all of that together, so 0 times negative 20, that would still be 0. So then I have a y-intercept of 0. Okay, and so those are all of my answers there. So I have my x equals 0, or my x-intercepts and all their multiplicities, and my y-intercept. Okay, so we're going to be doing this quite a bit, and so we will skip example B, because this will pop up again on the other side. All right, so let's talk about what that multiplicity does, because that's kind of important. So multiplicity. So what a multiplicity does is it helps us understand if our x-intercept actually goes through the x-axis or is it reflected off of the x-axis. So that's kind of helps us with that graphing. So for our multiplicity, if our multiplicity is odd, then we have what we call a pass-through. And we call it a pass-through because it will actually cross the x-intercept. So if we have a multiplicity that is odd, it crosses the x-axis. Okay. Whereas if we have a multiplicity that is even, so if we have a multiplicity that's even, we have what we call bounce. We call it a bounce, but it's just it touches the x-axis at the x-intercept. So that just means that it just touches and passes through. So it reflects off the x-axis. So if I take a look at here, I'm going to just kind of identify the x-axis here first. So this is my x-axis. And I want to look, everywhere that the graph, touches the x-axis, whether it goes through it or not. So the graph meaning the curve, right? So we'll just call this f of x. So where does it touch? It touches the x-axis here, 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 and here. So on this first one here, so because the graph was, below and above it, so it goes all the way through the x-axis, then that means the multiplicity is odd. Whereas right here, the graph goes down and then quickly turns and comes back up. So then the multiplicity is even. And again, we call it a bounce or reflection because it doesn't actually cut through, it goes down and comes back up. So right here, this graph, it goes all the way through the x-axis at that point. So that would be an odd multiplicity. So it goes all the way through. This last one, it goes up and it doesn't keep going, right? It turns and comes back down. So then that one would be an even multiplicity. So what do odd multiplicities do again? It goes all the way through the x-axis, right? If that's the x-axis. What does an even multiplicity do? So if this is my x-axis here, it tries to go up and then boop, comes back down. Okay, so it doesn't actually go through the x-axis. All right, here we go. So let's take a look at a few examples. Get these graphed here. So for this here, so the first thing I do is figure out my x-intercepts. Okay, so that's the first thing I do. So how do I find my x-intercepts again? I take each one of these factors and I make them equal to 0. So I'm going to take that x squared, equal it to 0. Take that x minus 1, equal it to 0. Keep in mind that's a power of 1. X plus 2, equal that to 0, also to a power of 1. Because that's going to matter, right? It's going to matter on my multiplicity. So I want to solve for x, so I'm going to square root both sides. And so that will just be x. Square root of 0 is 0. So I'm going to go to the x-axis, and I'm going to put a dot at the 0, and I'm going to remind myself that there's a multiplicity of 2, because that's going to matter. And then I'm going to add 1 to solve for x, so x would equal positive 1, and it has a multiplicity of 1 because it's a power of 1, right? So power of 1. And then here, subtract 2 from both sides. Oops, I forgot to put a dot. So x equals 1. So I'm going to put a little dot right there. And then what I do? Subtract 2. There we go. So x equals negative 2. And put a dot right there. Okay, so I have all my x-axis marked, and my multiplicity is 1. So then I'm also going to find my y-intercept. So remember, for finding my y-intercept, I take that equation that I have right here, and everywhere I see an x, I'm going to turn it into 0. So instead of x squared, it'll be 0 squared. And then instead of x minus 1, 0 minus 1, and then 0 plus 2. So 0 squared is 0, 0 minus 1 is negative 1, and then 0 plus 2 is 2. And then when I multiply all of that out, I will get a 0. And so y equals 0, so here's my y-axis. I already have a dot there, right? And that was for my x-intercept, so it's just going to be that same dot. So now what I have to do is figure out, what does my graph look like? So at x is equal to 0, I have a multiplicity of 2. So that means the graph is not going to actually cross through, it's just going to turn at 0. So that means, and I'm just going to do right here, make sure I turn the graph. Don't go through. Okay, so they call it a bounce. So I'm going to bounce there and not go through the x-axis there. So I need to make sure I pay attention to that. Okay. All right, so I'm going to look at my leading coefficient to figure out how my graph is going to end. So I look here, so let me show you where I'm looking. So I'm looking at this point right here. So that is x squared, but I can put like an implied 1. So my leading coefficient is positive. So what does that mean? That means my graph on the right-hand side has to go up. So I know it's going up because the leading coefficient is positive. So then I'm going to graph backwards. So graphing backwards, so I know it has to go through the x-axis, and then I'm going to have to turn to catch that intercept, right? So I'm going to turn and catch that. I don't want to go through the x-axis because I want to turn there because it was a multiplicity of 2. So turn it around. And then now I have to turn again to catch this x-intercept. So turn and catch that x-intercept, and it goes all the way through because the only one that bounces is at my x equals 0 because I have a multiplicity of 2. So I know it's a little confusing, but we'll do enough examples. Hopefully this will make more sense. All right, let's take a look at the next one. So I want to find my x-intercepts first. So I'm going to take each of these factors and I'm going to equal them to 0. So I have negative x is equal to 0, x minus 2 is equal to 0, and x plus 3 is equal to 0. So divide by negative 1, x is equal to 0. Add 2, x is equal to 2. Subtract 3, x is equal to negative 3. All of these have a multiplicity of 1. Every single one of them, because these are all powers of 1, right? There's not a single squared on here. So that means every x-intercept is going to go through the x-axis. All right, let's take a look at our leading coefficient. So our leading coefficient, so we're looking right here, right? So for that, our leading coefficient is negative 1, right? So LC leading coefficient, that would be negative 1. So it's going to be negative. So that means the right-hand side of the graph is going to go down. Okay. So let's get my points on here. So I have x is equal to 0. So that's right here. I have x is equal to 2. And x equals negative 3. All right, so I have no bounces, right? Doesn't mean the graph doesn't turn ever, it just doesn't reflect off of the x-axis. And I know the right-hand side has to go down. So the right-hand side goes down because my leading coefficient is negative. And the graph is going to cross at those points. So that means it's going to go above the x-axis, turn to get that dot, go through the x-axis, turn to get that dot, and that's it. And then boop, it keeps going. Okay? All right, let's take a look at the next one. Maybe. I can't get it to move. There we go. What is there? There we go. Okay. All right. So let's keep on. Okay. So same-o, right? We're still graphing. So what do I want to do here? So I'm going to take each of my factors and set them equal to 0. So I have 2 is equal to 0. I have x plus 3 squared is equal to 0. X minus 4 is equal to 0, and solve. Well, 2 cannot equal 0, right? So I get nothing out of there. Here I want to square root both sides, so and then I get x plus 3 is equal to 0. Subtract 3. So x equals negative 3, and I have a multiplicity of 2 because I have a power of 2. And then I want to add 4 to both sides. So x is equal to 4 with a multiplicity of 1 because it's a power of 1. Okay, so this didn't give me an x-intercept, so I'm not going to graph that one. So let's start with this one. X equals negative 3, 1, 2, 3. And x is equal to 4. So one right there. Okay. And then I want to find my y-intercept. So I'm going to take this same equation, and anywhere I see an x, I'm going to turn it into 0. So instead of x plus 3, it'll be 0 plus 3, and then squared. And then instead of x minus 4, 0 minus 4. So then I have 2 times 3 squared times negative 4. So 3 squared is 9, 3 times 3. And then, what is that? Negative 72, I think? I hope so. We're going to say it's negative 72. So the y-axis is not scaled on purpose because we do get big numbers like that. And so we just say, all right, somewhere down here is negative 72, right? Definitely not to scale, but it gives us the idea. Okay, so I know that I have a reflection, so I really have to pay attention to at x equals negative 3 that I reflect off the graph, right? So I'm going to turn at that point. I'm not going to go through at that point. So turn there, not through there. All right, so let's take a look at our leading coefficient. So our leading coefficient is a 2, right? But it's an implied positive 2. So that means the right-hand side is going to go up. So I'm going to start on the right-hand side, and it's going to go up. And it goes through the graph. I'm going to go and catch this dot down here, and then I'm going to turn to go catch the next dot, and then I don't go through, right? You need to turn and go down. So this is not there. Okay. All right, hopefully this is getting a little easier. Okay, so let's take a look at, I don't know why this is not wanting to cooperate very well. Okay, so this one right here, so part B. So same thing, right? So we have like that negative, so I know I can always put like a little 1 there. So I'm going to put a little 1. And then I'm going to create my 3. So I have negative 1 equal to 0. And then x minus 4 squared equal to 0. And x plus 1 squared equal to 0. So then solve each of these, right, to find my x-intercepts. Well, negative 1 can't equal 0, so that will not give me a solution. And then over here, I'm going to square root. So then that gives me x minus 4, because that will cancel, cancel, cancel. Square root of 0 is 0. Add 4. And so x is equal to 4 with a multiplicity of 2 because it has a power of 2. So 1, 2, 3, 4. And it's going to turn there, right? Because it has a multiplicity of 2. So I'm going to remind myself, don't forget to turn there. Don't go through, turn there. All right, let's take a look at the last one. So square root, cancel, cancel. So x plus 1 is equal to the square root of 0, which is just 0. Subtract 1. Check out your multiplicity of 2 because it's a power of 2, right? You're always, that power matters, so make sure you're paying attention to that power. So x equals negative 1, which is right here, has a multiplicity of 2. So I'm just going to do a little reminder to turn there, right? So don't go through at that point. You're just going to turn there. All right, and then let's find my y-intercept. So I'm going to just take that equation, and everywhere I see an x, I'm going to replace it with 0. So I have y equals negative 1, and then instead of x minus 4, that'll be 0 minus 4. Don't forget your squareds. And then 0 plus 1, and don't forget your squared. So I have negative 1, and then negative 4 squared, and then 1 squared. So that's negative 1, and then negative 4 times negative 4 is positive 16, and then 1 squared is 1 times 1, which is positive 1. And then let's multiply all of that together, and I'll get negative 16. And so then on my y-axis, again, not to scale, I'm just going to say somewhere around there is negative 16. All right, so let's find our leading coefficient. So I'm looking right here, right? So my leading coefficient is -1, so that would be negative. So that means the right-hand side goes down. Right-hand side goes down. So I'm going to go to the right-hand dot. So this is my right-hand dot, and I'm going to go down. And that's because my leading coefficient is negative. And so then I know that the graph is going to turn at that dot, right? It's not going to go up and through it. It's going to turn because my multiplicity was 2. So I have to turn at that dot, head to the next dot, which I forgot to put, which is my y-intercept. So head to the next dot right there, and then head to the next dot. And then do I go through? No, I want to turn there. So I don't go through. I'm just going to turn and boop. Not the prettiest of graphs, but there you go. And I think that was it, right? Did I do all of those? I just realized I totally did those out of order. So hopefully you're okay with that. Oh, sorry about that. Okay, that's the end of that one.